Oh, sorry about that, everybody. Me forgetting I don't have any of my just chatting stuff up. Clicking the wrong button. Couldn't possibly happen. This is Damie stream. I'm so prepared, guys. I am so prepared. Definitely, like, not prepared. You know, we're gonna see how it goes. Hopefully the music doesn't shut off this time. I did try and change some of my settings, like a good streamer. OMG, Damie live. Yeah, that's me. I'm live. I know, right? Crazy. I was gonna name this stream, is it even a Damie illegal problems stream if it's not scuffed? And then I realized I should probably not name my VOD that. If you're wondering where the other VOD went, if you were looking for it, thanks for looking for my VOD, especially one that was as silly as that. But I will be releasing the VODs for this specific problem set, either on YouTube or on Twitch. I'll be republishing them if you'd like to see them after this problem set is like turned in, because technically I'm not supposed to do it on here. I have a very painful blister on my foot, so hopefully the stream will cure me. This is not Studio Ghibli jazz. Let me change that. We are doing physics and math. There's one math problem I need to do, which was apparently the best problem out of the whole thing my teacher gave us. Oh, wait a second. Give me one second. My roommate's home now. Yeah, you can say hi.
Ice cream.
They're chilling. They've melted ice cream. That's a math problem, right? Ice cream melting. Hello, can you explain my Discord problem? Yes, I can. I hope you don't mean the rope one, because I can't explain that one. Not really sure how they want you to do that one. But I can explain the vector one really easily. Let me pull up my little, Ooh, my computer's getting nice and hot, nice and steamy. Okay. This is where we were. Whoopsies. Oh, actually, I'm gonna be real, guys. I cheated on you a little bit. I started doing this off stream, because I did need to do some of it. But let's go and do Blaine's. Is this on? Uh-oh. Tablet. Hello? Hello? Did this finally croak? I mean, I hope it didn't. I do have another USB-C cable if I need it. This USB-C cable that I use for my tablet is... Oh. Oh. Oh no, we're good. Okay, we're good. Alright. Let's do a little problem. Okay. So Blaine's problem was you have a function, right? To a tangent. I'll do like one of the easier ones. Wait, let me find where it is. Oh wait, do you want me to do the newest one? I'm gonna do the one that you... Wait, let me see. Number 37. Sketch the graphs... Wait. This is just graphing in 3D space. That's just like x squared plus y. Okay. Okay, here's the first graph. 4. There you go. The second graph. 4, but like a little forward. 2. 0, 0, 2. 0, 4, 2. It's not that bad, it's just a circle. And then you push the circle forward or up. Taking both Calc 3 and 4 and physics engineering is crazy. I'm not taking 4 right now, I'm taking 3. So that's parametrics, polar, and infinite series, and Taylor and Maclaurin series, which is power series. And then I am also taking... I'm just taking some intro engineering courses, so... Let me get a little sip of my drink. And then the unit vector problem you had, I think the hardest part of it is knowing that, like, let's say you had a function like this, right? Let's say you have this point right here, right? The easy tangent line to draw is this one, right? Like, you know that there's a tangent here, but what you have to understand is that, like, for a vector, right? A vector can only point one direction. A line extends infinitely in either direction like this, right? There's no direction of a line. It has both directions. But for a unit vector, it can only one direction. So you have one unit vector going this way and one unit vector going this way. That's why you have two unit vectors. Anyway, let me pull up. We're gonna do physics first because we love a little physics. I don't remember what this problem is, so I need to look it up real quick. Here we go. It's so funny because, like, redoing all this stuff is, like, really taking me back. Like, oh my god. Me, POV, you're me in my junior year of high school. I don't agree that they put me in this class, but you know what? I gotta take it. I didn't test out of it, so what can you do, right? All right. So we're doing this problem where we've got this funny little graph here for our position. Just constant acceleration. You're not too bad. No fancy stuff. So for D, it's asking at what time between t0 and t is 2 is the velocity of the particle instantaneous velocity not changing. So when is v equal to 0 between t is 0 and t equals 2? Well, that's pretty easy. We just put 9t squared minus 20t plus 9 equals 0. And I think this one sucks. I should probably get my graph. I think this one is not nice. Let me actually use Desmos. If I can give everyone one singular tip that you take away from my streams, Desmos is your best friend, and it got me through all of my math classes, so, you know, do with that what you will. What was it? 9x squared minus 20x plus 9. Okay, so our intercepts... Oh, nice Discord notification. Who is that? Which Discord is that? Oh. Different person. Oh, wait. Umbra. Where's Umbra? Umbra made me something? Oh my gosh. Oh, that's so cute. What? Wait, I'm saving this. This is so cute. Can I post this? Can you, like, tweet this at me so I can retweet it and be like, oh my gosh, this is the best thing ever? Here, wait, let me open it on stream. Okay, you picked it. I love my model. My model looks so, like, fucked up sometimes. My eyes don't open very wide, and also I wear glasses, so my tracking is, like, kind of shit. Wait, let me copy this. So I can show stream how cute it is. This is so cute. Aww. Look at this, chat. Look at this. It's so cute. OMG, Damie, hi. Aw, it's cute. Aw. It was really funny. I had a physics quiz the other day, and I drew this on the back of it. Roughly. Just like a big thumbs up cat. Like this. And my professor went, "What is that?" to everybody, right in front of everybody, and I was like, I don't want to talk because they're taking a quiz because I finished kind of early. I was like, I'm sorry, I just drew a big cat with doing a thumbs up on your quiz. I gotta do that. Okay, t equals. All right, what are our intercepts here? We have 0.627. 0.627, and t equals 1.595. He always wants to stuff seconds. See, okay. If I had done this, wait a second. Wait. Oh, it was asking for the velocity at the, wait. Yeah, never mind, that is velocity. I was like, bro, what? Yeah, because in part C, it's asking the acceleration can be, you know, you can be accelerating and have your velocity be 0 when you're, that's the turning point, right? So that's like right here when this is turning from the right to the left, like right at this point where it turns over here. Well, in this one, this is when it's going to the right and then it turns to the left, and this one it's going to the left and it turns to the right again. You can kind of think of it like if you, here, I can do it actually. If you turn it this way and then you like flip it. Wait, not that. Oh, I forgot I don't have any of my shortcuts. If you do this, that's what it looks like. This is what the motion actually looks like if you were to watch it. Except it would be like squished, right? There would be no forward because it's just a, yeah. Okay. Nice. Do we have an E? Of course we have an E. Okay. What is the particle's greatest distance from the origin between t equals 0 and t equals 2? Okay, so we wanna maximize x. Max x between 0, t is 2. Well, just by looking at it, I think it's gonna be here, right? But we can do a little maximization formula. Y'all remember that? Y'all remember how to maximize stuff from like from BC Calc? The way that we maximize it is we take the second derivative, so we have to say v equals 0, right? So these are our turning points, our local minima and maxima, right? Because when it's high or really low. So v equals 0 at t equals 0.67 and t equals 1.5. These are like local min max. And we just plug these in to our x function. So x of 0.627 is going to be a bad number. But what I'm going to do actually is I'm going to do 3x cubed minus 10x squared. Oops, sorry, I punched you. Plus 9x. And then we're just going to do x equals 0.67, and we're going to see where it intercepts. That's at 2.451. And then our other one is going to be x of 1.595. Oops, 595 is going to be 0.555 is going to be, whoa, don't do that. Oh boy. I'm zooming in, I'm zooming out. What's happening? Where am I? Oh boy. Go to the function. Oh no. You guys can't see this. I'm struggling. Where is it? It's zoomed in too far. Go to it. Click on it. I just want to go. How do I go to it again? Forget. Hello? I know you can click on it and to like view it. Desmos? I'm a Desmos enjoyer. Oh wait, did I just graph this completely wrong? Wait. Okay, it doesn't go down that far. It doesn't go down nearly that far. Bro, what was I doing? I wonder if I'll get mad at that. Yeah, I should probably redraw this. I didn't check it because I was like, you know, I shouldn't because I wouldn't on a test. But, you know, It's okay. It's just a little secret between you and me, chat. Right? Only us. So it goes more like... Wait, but it changes concavity. Oh, that's gonna be so hard to draw this. Kind of like that. I need this to go like up more. Like that. See, all that matters is that I got like the concavity right. Right? That's what we care about. We don't really care about the values. So it's furthest position from 0 to 2, and then we also have to check 0 and 2, right? X of 0 is going to be 0, and x of 2 is going to be... It actually might be x of 2. But x of 595 is 1.088, and then x of 2 is going to be 2. Just like sanity check that. 8 times 3 is 24 minus 40 is like 16 plus 18. Yeah. Poggers. So this is our winner. So at t equals 0.627 seconds. Look at that. Hell yeah. Hell yeah. Doing things. Working. Do a little like, I'll do a little heart instead because the check mark could look like a V. There's no heart symbol in math. I feel like people should use a heart symbol in math. Anyway. Okay. At what time between t0 and t2 is the particle speeding up at the greatest rate? Okay, speeding up at the greatest rate. So this is going to be a little tricky because we want to say like a equals, you know, max positive, right? Now what he's trying to say is, right, if you have, so acceleration being positive doesn't always mean that it's speeding up, right? We think of that, but if acceleration is in the same direction as velocity, that means it's speeding up. So if you can have a max acceleration that's negative, that could be the max acceleration that is speeding up the object if the velocity was negative at that time, right? So it's like going to left and it's accelerating to the left, then it's speeding up. But if it's going to the left and accelerating to the right, then that would be slowing it down. So we gotta check A is max positive, is max up, but we basically just have to say like A sine, max A sine equals B sine. Or let's, yeah, we want to say max A sine equals B sine, right? So we can have a, it's a little hard, but we'll get there. So finding the maximum minimum is not bad, right? So we need to say when A, or when, yeah, when, wait, we want to maximize acceleration? Oh, okay, when then D, wait, when it's speeding up at the greatest rate. Okay, we want to maximize velocity is the thing. No, but the greatest rate, you want to maximize, okay, no, we want to maximize A. So we need to maximize, we need the derivative of dA dt, which is going to be 18. I think he wrote this question wrong. No, we want to maximize V then. But the thing with maximizing V is, when does the... Huh? The acceleration is constant, bro. The maximum V you're gonna get is like at t equals 2. Am I tripping here? Because like, if we want to say when is the greatest speeding up happening, it would be as far here as possible because it's accelerating more and more, right? Wait, okay. Big brain time. Big brain. Wait. 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 Whoa, why did I turn? Oh, uh-oh, it's not doing the right thing. Big brain time. Huge brain time. Okay. Let me think. It's speeding up at the greatest rate. The greatest rate is, there is no greatest rate. It's always 18. Or no, it's not. It's fucking... Oh, my brain. My big brain. When is the particle speeding up at the greatest rate? I'm losing it. Okay, wait. Okay, let's eliminate something. So we know that it has to be either we're maximizing velocity or we're maximizing acceleration, right? If we're maximizing velocity is a rate. When is it speeding? So clearly what he's trying to say is like, make sure you know that the signs don't have to always be positive, right? So like, it could be a negative velocity and a negative acceleration, which makes me think that we maximize velocity with respect to acceleration. We're gonna do that, chat. If that's not it, then I'm gonna cry. Okay, so we're maximizing velocity then. Right, so that means we need to say when A is, I mean, we basically just need to check the ends, because A is like, okay, we'll just check like A equals 0 at, when does it equal 0? A equals 0 at t equals 18, t minus 20 equals 0, t equals 20 over 18 equals 10 over 9, equals in big boy decimal numbers, what does that equal? 10 over 9? 1.111111. So 1.111. And we also check. So V at 1.111111. Then we also check V at 0, and we check, oops, okay, maybe I should, V at 0, V at 1.111111, and then V at 2. So V at 0 is gonna be 9. V at, I don't know what V at 1.1111 is, we're gonna see what it is. 1.111. Whoopsies, x equals negative, right? So negative 2.11111. And then V at 2 is going to be what? Whoops, is going to be 5, right? Okay, so now we have to check what A is at all these times. So A at 0 equals negative 20. So this one is not it. A at 1.11111 is going to be 0. Which I guess when is it speeding? But like it says, when is it speed? It's technically not speeding up at all then. I'm losing my brain. Anyway, a at 2 is gonna equal positive number, right? So like positive, I don't know, positive, what is that? It's like 18 times 5? Or no, 18 times 2 minus 20. 18 times 2 minus 20 is, we're gonna, oh god, 18 times 2 is 6, that's 16. Okay, so this is the right one. So when t equals 2 seconds. And then for g, this is when is it like, you know, slowing down at the most, which is just going to be our other one. This is a poorly written question. I would not write it like this. I remember in my calc class, there was this question about like a grain silo. Like grain pouring in at a certain rate. And there was a similar thing to this where it was like, it said it was like, what like rate is it speeding up at? If you say what rate is it speeding up at, like you're talking about the acceleration, but like sometimes it was hard to figure out. Sometimes it's like, is it talking about like when you say you want to say, is the particle, if you say at what time is the particle speeding up at the greatest rate? Speeding up implies that that's like accelerating. So you're trying to maximize acceleration. What time is a particle like moving at the greatest rate? But I don't know. It's annoying. Maybe it is maximizing acceleration. I still think it's gonna be 2. But then slowing down, we kind of use the same, same data from f, and that'll be it'll be t equals 0. A sine does not equal v sine. Okay. Cute. A sine equals, a sine equals v sine, speeding up. Even if it's not right, you know what? This is what he's getting. Slowing down. Cute. I bet they're gonna like locate these points on the v and a graphs. Okay. We're just gonna do it in like this red. So here, and like we'll just say this is 2. I don't know. That was 1 is the here 0, or when t equals 0, t equals 2. Then here this is t equals 0. T equals 2. Is that an intercept on this one? Where does t equals 2 land us? No, it's way past the intercept. It's like over here. I mean, makes sense, right? Velocity is positive and the slope is positive. Velocity is positive and the slope is negative. Cool. Awesome. All right, let's see. We're nearing the end. Hopefully we can like finish this today. I'm just gonna stream until I finish it. Not kidding, I'm not leaving this. Wait, why do I have so many problems left, bro? Why did this one have so many parts though, like for real? Anyway. This was 9. Oh my god. We're not even like, we're not gonna think about it. We're not gonna think about how many we have left, okay? Okay, 10. Position of particle moving along the x-axis depends on the time according to the equation x equals c t squared minus bt cubed. What units must c and b have? So x is in meters and t is in seconds. X meters, t seconds. Well, if t is in seconds, and we need to get to meters, then this has got to be in. So if this is meters equals something like, you know, unit times seconds, we kind of need this to equal the same thing. So it's going to be like seconds over meters. Although it's not really how it works. Is that true? Let their numerical values be 3 and 2 respectively. Does it need to be seconds? I guess it does. So C equals seconds over meters? I feel it's just like... Oh, shoot. It's not because it's squared. So this is seconds meters squared. Oh, but it's not even that. Okay, C is gonna equal 3 seconds squared over meters, and B is gonna equal 3 seconds cubed over meters. I think... Wait, no. No, meters over seconds squared. Oh boy, oh boy. Meters over seconds. Okay, so meters over seconds squared. So that's like acceleration, and this is meters over seconds cubed. And that's something that doesn't exist in physics. Kind of awesome. Kind of poggers. This is just A. I'll just put it in there. Close enough to A. Okay, B. What have we got? At what time does a particle reach its maximum position, maximum positive x position from t 0 to 4? So 0. This is great. We're just getting some like maximizing problems in here. So we've got 2 times what is our c? 3. So 6t minus 9 t squared. 2 times 3, 3 times 3. And now we have to say, when does this equal 0? T equals what? So, t, 6 minus 9t equals 0. T equals 0. T equals 9 over 6, so 3 over 2. And now we gotta check our ends, so we're gonna say when x of 0, when x of 3 halves, and when x is 4. Okay, x of 0 is gonna be 0. Nice, easy. This x of 3 halves, we're gonna plug this in because I am not bothered to. So 2x squared plus 3x cubed, right? Nope, that's a 3. Don't know why I wrote that there. That's supposed to be a 2. No, that's supposed to be flipped, isn't it? Is it actually? Yep, 3 and 2. Awesome. Love the big dyslexia for the win. It's fine. Normal. 2. Which means that this is not 9. That means that's also 6. That's fine. It's not 3 halves, it's 1. That's nice though. Let's just do it in our head. Still a 9. Okay, for 1, that would be 3 times 1 minus 2 times 1. Negative 1. Just look. Wait. No, it's 3 and 2. 3, 2. Yeah. squared x equals 1. If x equals 1, it's not supposed to equal that. What? Oh, it's not because of the running a plus, not a minus. There we go. Wait, x equals 1, it's supposed to equal positive 1? Oh, it does equal positive 1. Okay, I'm smart. And then x equals 4, it's going to equal 16 times 3 minus, I don't know, it's like a big number. X equals 4. We know how to calculate things. Oh my god, wait, that's a really big number. What? Okay, I don't really want to do that. So 16 times 3 times 3 is 48 minus 2 times 4 cubed. Negative 80. Nice. Well, I think we found our maximum position. Woof. Yeah. Oh wait, maximum positive x position. T equals 1. Yeah, it's gonna go down to negative infinity forever after that. Yeah. Nice. Except for the negatives, but, you know, we don't talk about the negatives because it's physics, so. We're not like Dio or whatever. Can't redo time. Let me move this down a little bit so we can get that better. Nice. Okay. Oops. Big smudge on my paper. I love that. Okay. Let's see. What distance does the particle move and what is its displacement? Okay, so distance versus displacement. Distance is the full distance it's traveling, so we could do arc length, or am I also smart? Wait, for t. Oh, wait. Oh. Whoa. Oh, okay, that's fine. This is not actually t equals. They said t equals, so this is t equals 0 to 4. Doesn't really matter. I thought they were saying that for the other one, but okay. What distance is particle? Okay, displacement is easiest, so we'll do displacement. Well, that's d. What distance does a particle move? Maybe we can calculate that with arc length. An integral. I only remember it for parametrics. Length function. Smart. One plus, okay, so our integral is 1 square root of 1 plus dy dx squared dx. Awesome. So our dy dx is going to equal what? Our dy dx will equal, we calculated over here, 6t plus minus 6t squared. Ironically enough, this problem also came up in my math, and it took me way too long to realize that I forgot the squared for the t, and it was an embarrassment. Okay. So we got 6t, 1 minus t. I'll make it a little bit, will it make it a little easier to square? Maybe not, but we'll do it anyway. Anyway, our little integral, we're gonna do 1 plus 36t squared times 1 minus t squared. We can change the 1 minus t squared to 1 minus 2t plus t squared. Get this out a little more. Don't forget the dt, otherwise they will crucify you, I guess, or something. I won't. I mean, do it though. 36t squared minus. What is 36 times negative 2? What is 36 times 2? Oh my god, times 2. 72. Negative 72t cubed plus t, 36 t to the 4th dt. Does that do anything for me? That's kind of lame. Wait. Wait, I'm so dumb. I can just integrate the velocity. Bro, I don't need to do arc length. Bro, this is not a hard calculus class. I forgot. Okay, I'm overthinking. I'm doing parametrics and math. I'm like, bro. Oh, just integrate the velocity from 0 to 4. Okay, 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 okay. You know what? I'll take it. That's easy. All right, so we do 6 over 2 t squared minus 6 over 3 t cubed from 0 to 4. That's so funny. So this is a 3, and this is a 2. So we're gonna get 0 minus what was that? 3 times 16 minus 2 times 64, which will equal negative 16, so positive 16, so 16 meters is our distance. Okay, so that's how far we went. Or wait, no, actually that might be displacement. Am I lying? Let me think about that. I'm fairly certain that's displacement. Is that true? Let me see. Find distance physics. Yeah. Well, we could do like a little kinematics. We don't have an acceleration. Wait, do we have a constant acceleration? No, we don't, so that won't work. Am I thinking about something correctly here? Distance from velocity. Well, this one says displacement slash distance area under graph. Not true. I mean, I could do the distance. I could do the distance on one side. I could integrate up to the Here, do I have a picture of this? It kind of looks like this. Right? Kind of looks like this. So what I could do is I could integrate this, and I could integrate this, and add them together positively. Because what I think is happening is that I'm integrating this, and it's just combining, like I'm integrating from here to here, from here to like here. And I think it's just getting rid of this, but I need it to be like the absolute value. So we can integrate, we'll do that, we'll do that. Although this is perfectly good work for the displacement. I think it's 16. Well, displacement has a vector, so it would be negative 16. Is that true though? Like from 0 to 4, x equals 4, it's like gonna equal 80. Am I like tripping? Yeah, that's not gonna equal 16. How does that equal 16? What? Someone's lying. Do I need to change the factor for that? Like, do I need to integrate it with respect to the y-axis? No, that's impossible. Let me get rid of all this. Let's just start clean. Sometimes you just need to take a step back, wipe the board clean. Let's look. So what distance does the particle move? So I can trace out the distance formula with like an arc length. And that will definitely, well, let's do this. You know what? Let's take a little field trip, chat. Let's take a field trip over to my Desmos. I need to make sure to not dox myself, but it'll be fine. I'm not gonna dox myself. Oh, let me, before I do that, let me just ping my other Discord real quick. that I'm streaming. I'm streaming. Because I always forget to ping them. Teehee. Okay. So okay, now we can take a field trip over my Desmos. That's code capture. Where's my code capture? Okay, you guys can see that, right? Oh, it's kind of scuffed. Where's that? Get out of here. Why is you scuffed, little guy? There we go. Perfect. Couldn't tell if that was overlapping. Okay, what we can do is this. We can do a little arc length formula, right? So if we do integral from 0 to 4 of, we can just call this like y1. Okay, maybe we can't call it y1. That's fine. Of square root, I don't know why I did that, square root of 1 plus this equation, d dx, whoops. I think I need more brackets. I think that's how you do it in Desmos, like a d dx. What is it? What are they saying? Oh, it doesn't have a dx. D over dx squared. Okay, we got 82. Yeah, okay. We got 82. So what we were doing before was not correct, right? So that is the distance, right? If we do the arc length. And that makes sense, right? Because we're moving 80 at least over there. And like this thing could be 2. Yeah, I could see that. If you lay this flat, like yeah, that could be like 2-ish, you know? So that means we gotta do it a different way. The way that I can possibly see doing this is if we do the integral from 0 to, what is this intercept? 0 to 1.5 of the derivative of this, that would be 6x minus 6x squared dx. Where are you? Okay, it's mad at me. What? Why is it 0? Hello? Why is that 0? What? Wait, what? Oh wait, it's because it's the derivative. No. What? Why is that 0? Anyway, but let's just like see the other side of it. 1.5 to 4 of 6x minus 6x squared dx. Negative 80. Okay, so that one works. Why is this one like not working? Hello? Hello? Are you integrating? Are you an integral? I don't know why. I don't know why this isn't integrating. That is very strange to me. It should be a negative number. Because like to 1.5, 1.5, 6 1.5 minus 6 1.5 squared should be a number. Like what? Why is that not right? Hello? What if I do like 0.1111111? Why is that so... I'm so confused. Why is it 0? Yeah. Should not be that so slow. What, am I going insane? I mean, yes, all the time, constantly, but why Why is that? Chat, you see this, right? Oh, wait do I need to integrate? Wait a second. Wait, I think, no, I don't want that. I want the difference between, because like if you integrate the velocity, let me see what this looks like. Let me graph the other one of this. Sometimes you just gotta graph a lot of stuff. That's what physics is about, right? Okay, this is the velocity. Bro, why is that not integrating right? Hello? Oh, is that because it might be because I'm integrating to 1.5 instead of 1? It's 1? What? Why is that 1? And then 81, negative 82? That's not the right thing though. Why is that one like more right? I'm so confused. It shouldn't be more right. It should be the same right. Umber's giving me hype in the chat for just failing math problems. It's beautiful. Why? Why would they be different? Okay, you know what? We're gonna do patented damie technique. You made me calzones? Oh my gosh, that sounds so good. We're gonna do patented damie technique. You guys ready for this? Are you guys ready for this? It's a really good technique. I actually think everybody should do this. It's really awesome. You know, once I learned this technique, it's kind of life-changing. It's called we're just gonna not do it. And that's it. We're just gonna leave these two alone and we're gonna go do the next one. Okay. Let's see. All right. Plot X versus T for the... Wait, that's a different problem. Okay, we can do E and F. E and F are chillin'. Holy shit, he's a professional. Yeah, guys. Learning only professional tips here. Vector calculus graphing is crazy. What are you graphing? I mean, I've worked with vectors. I don't know if I've done technically like quote unquote vector calculus, but like if you have a question, like I can try and answer. I haven't really worked in three-dimensional space, but like I know about three-dimensional space because of physics. If it's not trig in 3 dimensions, if it's mostly just like linear stuff, like I can probably do it. Okay, at times t equals 1, 2, 3, 4. We need the velocities and accelerations. Okay, that's easy enough. Just gotta fucking plug shit in. I'm not even gonna bother writing this out any more than it is. We're doing a subset, chat. We're doing the brackets. We're pulling out the brackets. Oh, can I explain sig fig? Oh yeah, sure. Okay, let's take, what's a good thing to take? So like, all right. Let's take one of my answers here. Let's take we'll take 1.111. So we got a number, right? Let's say it's 1.111111111 repeating. This is good, right? We know this is an accurate number, and we know that there's an accurate fraction that works with this number. But realistically speaking, it kind of sucks, right? Like we don't want to have to write out all these ones. And we honestly, when we get down to this place, we don't need that. So the reason why we use sig figs is because we want to constrain our problems to a certain accuracy, right? So sometimes when you measure stuff, right, if you're using a millimeter that has like an inch here, wow, millimeter. You're using a ruler that has like a centimeter here, right? And maybe it's got millimeters, right? But it doesn't have anything smaller than that. You can't accurately say how much is like in between this, right? You can guess, but we don't actually know how accurate it is. So sometimes we need to constrain it. But what kind of rules can we use to constrain it? So with something like this, yeah, uncertainty, totally. It kind of allows us to hold ourselves to a standard no matter what the standard is. Like it doesn't, not every single measuring tool is going to be perfectly accurate, right? And we can't assume that. So let's say, so my professor wants us to use 3 significant figures. That is what is said in a physics lab class, boring as hell. Yeah, but it is kind of practical, right? You know, it just depends on the tools that you use, or in some cases, what problems you're given, or what your professor wants you to use. So sig figures with a number like this are super straightforward. So every number, right? Every number you see that's not a 0 basically counts as a sig fig. So let's say we want to make this 4 sig figs. We're just gonna go 1, 2, 3, 4. Bam, 4 sig figs. Let's say we want to make it 3. 1, 2, 3. 3 sig figs. Let's say you had a number that was like we'll do 3.14159. Right? Let's say you want to do 3 sig figs on this one. Well, it's not a 1 after, you've got a 1 after it, so you're just gonna go 3.14. Bam, 3 sig figs. The other thing you may see when you're talking about sig figs is scientific notation. You're gonna have to bomb the sig fig quiz. Oh, don't worry about it. Don't worry about it. You got this. You got this. There are some other rules, like let's take a number like 0.0057869. I'll just say millimeters or something. I don't know. We'll say meters. So it's in number form. Let's say you want to translate this into a usable physics thing, right? Because we got our 8 sig figs. Okay, so here's the thing. You got all these zeros up here, right? These are called leading zeros because they come before the other numbers. Now these zeros, right? They're going to tell us how small this number is. But they're not technically sig figs. Because sig figs are something that helps us actually create the number, right? We know that like we have our units of tens or whatever, that tells us like the magnitude of the number, right? But these numbers right over here are like the meat, right? That's the meat of the number. If you change one of these, if you change this to like a 6, then oh boy, that's crazy. Now you're like, okay, Damie, yeah, but like if you change one of these, then that also changes. And you're right. But because we have scientific notation, scientists kind of like to use different magnitudes to describe things, right? So for example, if we wanted to write this a different way, we could write this as, if we move the decimal point, we could write this as 5.7869 times 10 to the 1, 2, 3 minus third meters, right? And when we write it like this, those zeros aren't there, right? These zeros get conglomerated into this. So we don't count leading zeros as significant figures. But if you have something like 0.0057869, so this is 1, 2, 3, 4, 5 sig figures, right? You're basically the bottom rule for sig figures is you're counting the numbers that are not 0. But if you have a 0 at the end, past your numbers, that one counts as a significant figure. Because this now becomes part of the number, right? Like let's say there's like a 1 in here. Right? Let's say it's 0, 1 after this. Now, if you change this number, this matters, right? This is not demonstrating order of magnitude. This is demonstrating the actual, it's part of the number. It's part of the thing you're measuring. So we have to count this as a significant figure. So this one would be 1, 2, 3, 4, 5, 6, 7 significant figures. And if there was no 1 here, it would be 1, 2, 3, 4, 5, 6 significant figures. And the way that you would write this is in scientific notation, right? If we want to, basically scientific notation just gets rid of the leading zeros, right? You move this until you get a decimal that starts with a number here. 5.901 times 10 to the negative third. Now let's say you want to convert this to, I don't know, 3 sig figs. Easy, you just go 5.78. And since this is a 6, you can round up, or you can also look to the other number. This is a 9. You're also going to round that up. So it's definitely going to round this 8 up. So you can round that up to a 9 times 10 to the negative third. There you go. You've made your 3 sig figs, your 3 important numbers, right? Because these are about, this is what you need to like know what number that thing is. The zeros, that's an order of magnitude. You're not gonna, when you get into something like as big as the sun is or something, you're not gonna be messing up how many zeros are in front of that. That thing's big. But yeah, sig figs, once you start to use them, you'll get a little bit more used to them. Most professors usually say 3 or 4. Most of the times it doesn't really matter unless you're in a lab. Gonna be real. Yeah, basically, you don't even have to use sig figs in the middle of a problem, right? So like, let's say, like, see over here? Where's an example of where I did this? Did I do it in one of these? Sometimes you'll see me writing... Oh, maybe I didn't do it in any of these. Oh, this is kind of a better example. Davey can't read this. It's hidden. Like, see, like, this has 4 sig figs. My professor only wants 3, but you don't want to round up because, you know about rounding, right? It'll get less accurate if you round a lot, so basically just worry about sig figs at the end of the problem. Doesn't really matter otherwise. Like, we can do this with this velocity, right? So if we have t equals 1 and we want to find the velocity, Jesus Christ, where am I? T equals 1. Our velocity is going to be 1. Doesn't really matter about that. Let's just make sure logically. Wait, yeah, 3 minus 2, 1. If we have t equals 2, that's going to be, I don't know. Oh, well, let me write this out for like 3. Let's do t is 1, or fuck, x is 1. 3 minus 2, this is 1. How do I figure out the velocity of your car? Okay, well, which way do you want to do it? You want to do it with energy or you want to do it with kinematics? There's a dope answer and there's a lame answer. 3 times 2 squared. Vroom. Well, actually, the easiest answer there is look at your speedometer. You don't own a car. Slay. One of my favorite things was like, there was is this like story about a physics class that they were supposed to find the altitude at the top of the building, and they were only given a barometer or something. I can't remember. And like, there are a couple ways you could do it. You could like, and you needed to find like the height of the building or whatever, or it was either height or altitude or something. And they were given a barometer, and you could do it like by shadow length, or you could do it by other stuff. But like, one of the answers is you could go up to the top of the building and ask the CEO how tall the building was in exchange for a fancy barometer, and have him give you the answer, and that would also give you the right answer. And I think about that a lot. Because you know what? Sometimes you just gotta do that, right? Sometimes you just gotta trade your barometer for shit. You don't always need to work everything out. Okay, 3 times 3 squared, 3 cubed. I'm here to offer you a fancy barometer. Trade offer accepted. I feel like this is okay. He won't get mad at me, probably, if I do this. Hopefully he doesn't get mad at me. It's like, bro, what am I supposed to not use a calculator during this? Negative 27. And then x equals 4. Trade offer. You get barometer. I get Minecraft time. Bro, I want to play Minecraft. My computer is just literally, I tried to move all my files over and none of them moved over. So I'm trying to like get like people back at my house to get me a backup of my computer. But Minecraft will make a resurgence. I swear. I swear. Ugh. I feel bad because like I want to play it. Also, I got Slime Rancher 2. Would you guys want to see me stream Slime Rancher 2? If I could like actually get it to work. My gift is just sitting there, bro. I want to go on it so bad. I want to write my little code for my robots. You're making me sad. I want to go on so bad. I miss Minecraft. I'm gonna be real, guys. I just went cold turkey after playing it so much. It's like, it's so funny. Other streamers be like, drops a game because because they don't want to play it anymore. Me drops a game because I have to move. Wait, I don't want that one. I want the intercept. There we go. -80. That was the velocities. That makes sense. Wait, was that? Yeah. Wait, did I just... Did they say the positions of velocities? I'm gonna cry. No, velocities! Bro, I'm going insane. Oh, that was, oh boy. Fuck. God damn it. Autopilot. Why did I put in X? I even wrote X. Oh my god, okay. You know what? I deserve that. I was talking about like barometers and stuff. Well, at least they're slightly easier to calculate because it's only like 1. So that's what, 6 minus 6 equals 0. That's sad. That's sad. That is sad. Okay, fine. V equals 2, you're gonna get a 6 times 2 minus 6 times 4. There's gonna be negative 20, negative 24, negative 12, 5. Oh wait, x equals 1. Oh, I'm losing it. I'm losing it. X equals 2. Negative 20, negative 12. Awesome. I love that I can do math. 6 times 3. Luckily, my CMST class doesn't penalize late homework. I can bomb all the CMST assignments in one day. CMST stands for what? 9. That's a 3 difference. That'd be negative 18. I think, right? Oh, communication? I have a communications class. Negative 36, I lied. Wait, 6 times... Oh, yeah. And then we have 6 times 4 minus 6 times 16. That's going to be 6 times 12. I don't really know what that is. What is that? It's probably really big. 72. Yeah, that works. That checks out. I hate stuff that's busy work. I'm not going to lie. Like, I get that this is, like, useful, but, like, bro, this is hella busy work. Like this specifically, it's like, oh my god, I get 2. 2 is okay. 4 is way too many. Like for like, I get it, like if you have the option to do it, you know, but like, oh my god, so many. Okay, A should be easier. Even easier, right? A of 1. Let me just write A equals, right? Because we don't have that yet. A equals 6 minus 12t. Okay, 6 minus 12 equals negative 6. 6 minus 24 equals negative 18. 6 minus 6 times 3 equals... No, I lied. 6 times 2 times 3 equals, negative... Wait. 30? Negative 30? What is this noise in my ears? 6 minus... Okay, you know what? It's fine. 24 is 6 times 2 times 2. I think. I'm just gonna check it. What was I talking about? Communications? Comms classes are like kind of boring. Gonna be real with you. Not really much you can do about it. Yep, negative 42. I could just have a little program in my brain to write this out, but you know what? That is close enough to what I just did. Oh my god, wait. Meters per second. Meters per second. Meters per second. He's gonna take points off if I don't write meters per second. I feel like he should know. Like, bro, I don't want to write this out a bunch of times. There we go. It's like, the whole thing is meters per second, you know? I have some awesome classes this quarter. Oh yeah, my school's on a quarter system also, so 10 weeks for each class. That means I'm 10% done already. With my current classes. But they cover, like, kind of less for math and physics, I would say. Like, I still have to take a full year of physics, but it's interesting. I kind of don't hate it, because, like, I have this one class I don't like, but it's only once a week, which means that I only have to do, like, 10 classes, which is kind of awesome. I mean, and, like, I don't think I have a final. All right, what are we doing? What are we doing? What are we doing? All right, more boring stuff. You know what? You guys are the real ones. When I'm like popular or whatever, you can be like, you know what? I was on Damie's streams when he was doing the most boring physics problem set I can think of. I should give you guys like a little badge, like it's like. I survived Damie's 4 hours of boring physics stream. The first one is going to be so much more boring than the other ones. I feel like I'm going to bite my, like I'm going to eat my words after the other ones are like even more boring, but I survived Damie's, well, that's not how you spell. Damie's 4-hour boring ass 141 problem set 1. You know, it makes me feel a little bit better though that there's like no one here. Well, not no one. You guys are, I love you guys. But like if there was anyone from my class here, I would have to block them. And I'd feel so bad. Okay, what should we listen to? What music should we listen to? Any recs? If there's none in like 2 seconds, I am just gonna play something. I'm gonna play Splat is like a little too much. What about Breath of the Wild music? How are we feeling? That's 6 hours long. Okay, we'll do the nicer one. That's Rain. I listen to this one way too much. The music I listen to for my math work, I have 2 things that I listen to. I listen to only Studio Ghibli Jazz. Oh my god, I haven't changed my... I listen to only Studio Ghibli Jazz, the exact same video, and I listen to only this. This is like the 2 things I listen to. I never get bored of it. Oh, this is LST. It is nice having 2 monitors because I don't have to like tab back and forth to like look at your guys' messages. I just have to look over there. Okay. Oh god, there's still so many problems. Why? Okay. I just wish I could do that. I don't want to have to like... I don't want to have to, like, graph stuff, you know? I just want to plug numbers if I'm gonna I want to turn my brain off, I want to plug numbers. You know what I mean. You get me, chat. You guys get me. Okay. Okay. It's funny, though, I was watching a podcast that was, engineers. It was a mechanical engineer, an electrical engineer, and then one guy who didn't have a degree but started a degree, and they were like, oh my gosh, all the stuff that you learn in engineering school is so useless. And I'm like, I'm sitting over here having like first quarter, I've got a welding class, which is practical applications of welding. It's a welding lab. I have another lab class that like we're taking apart like engines and like drill motors, like putting them back together. And I'm like, okay, maybe my school is just like a little more hands-on with stuff. So I'm pretty glad with that, honestly. Because like I personally like a lot of like the theory, a lot of the concepts and stuff as well. I don't think it's particularly boring, especially if you have a good teacher. And none of my teachers are particularly boring. Not enough to make interesting material bad. So I don't know. I think that and then I had a professor who's like, you're only going to use 10% of what you learn in college, in industry. And I'm like, okay, but you're kind of wrong. Because, I don't know, people say like, oh, you're not going to use anything you learn in high school. Like, when have I used like sine or cosine or trig? And I'm like, you didn't use them. But there are so many things in this world that are either developed using math or like have those properties. Like you listen to sounds every day. That's interacting with trigonometry, right? Like waves, like radio waves or audio waves. And not that you have to like use that, but you're like interacting with that and you learned about that part of the world, which is so awesome. Or like let's take like this, you know, my welding class. Yeah, I may not actually be a welder. I may not weld. But like if I design a product that needs to have welds in it, like I interact with that. Or if I go outside and I look at like stuff that's been welded, I use products that have been welded. It's like you have a better view about the world if you take that class. Or people are like, oh, history classes are so boring. Like, but yeah, but you interact with people who are different from you on a day-to-day basis, right? It's like even if like let's say you had to like learn, you know, ancient Chinese history or something. Yeah, you know, you may not be quizzed on that every day, but when you meet a Chinese person, you know more about their culture or more about their history or more about their country, you know, and that's completely useful. I don't know, I think people are just like cynical, or maybe they don't see connections. I'm a very connections-based guy. So I like seeing like how everything is woven together. Okay, good. We've got some good stuff here. What is the position of the particle at t equals 0? Okay, so x of t, or x of 0, x of 0.5, and then x of 1. So x of 0, right? If you put something in 0th power, that's going to be a 1. Oh, 15 times 1. Or we'll do this. We'll do it. 15 times 1 is 15. So 15 times e to the negative 0.5 equals, or we'll do negative 1/2. That makes it a little bit better. Negative 1/2. If you put something to the negative 1/2, that is effectively the same thing as saying 15 times 1 over, right, 1/2, 1 over, for the negative, sorry, 1 over the square root of e, which is going to equal something. And then we've got 15 times e equals 15e. Right. I don't really think I need to simplify that. I think that he probably doesn't care. 15 meters. Let me do it in a little bit of a. Let me do it a little bit of an array here for the programmer in me. 15 meters, 15 over square root of e meters, and then 15 meters. Okay, let me go turn on the lights real quick. I am sitting in the dark. Awesome. One other thing, I don't know. It was interesting. One of my professors was talking about how he was like, oh, I wanted to be an engineer because it meant I wouldn't have to write. And I think a lot of people think that in STEM, like you don't have to be good at writing or you don't have to like really think about communication as much. But honestly, like, I don't know, again, maybe just a little angel catboy teacher, but like, I love communicating ideas to people and thinking about different ways that we can connect things in people's brains. And making it the easiest for people to relate to things or understand things or realize why things are important, because so much of math is just like, you know, convincing people that like something is actually useful, because people for some reason people are like, well, this thing's not useful to me, so I don't want to learn it. When for me it's like, you know, I personally don't want to be a civil engineer, but would I take a civil class on like materials, like properties? Yeah, that would be dope as hell, just because it's interesting, you know? But everything kind of is useful, I think, if you attempt to make it useful. So we need to find the average velocity of this particle between 0 and 1. So average velocity equals distance traveled, right, over time taken. So from x equals 0 equals 15 to x equals 1, 15e. So this will be right. And it's nice because it's over 1 second, right? So we'll just pop this in here. We can just do. I like to do a little arrow like this, where we say arrow like this, right? So you can see that we're using this stuff in here. So 15 plus 15e meters over 1 second. That'll give us meters per second. We can just kind of pop these in here. I'm going to clear out my Desmos, even though you guys can't see it. 15 plus 15e is 55. 55 point. Oh, and here we go, sig figs again, right? So let me write out this whole number. 55.77422. Oh god, it's running into that one. Right, this is too. I didn't even write out the whole number. That's way too many numbers, right? Normally I cut off at 4. So in this case, because it's 4, right, you'd round that down, but you'd extra round down because there's a 2 after it. So, yeah, we'll do that. Meters per second. And let's just look real quick, because we can. This equals the average velocity, first off, so, you know, that's maybe not a super accurate representation, but let's just look at what this function looks like, which is always a fun little activity. X equals 15e to the negative t. Where are you? Where are you? So okay, let me switch this over. So we can kind of zoom in on a little point here, right? Because we got to go from x equals 0, which is, you know, there, to x equals 1. From here to here. Where are you? Come on. Give me that intercept. Is there no intercept there? No, that's a lie. Oh, it's an asymptote. Anyway. But this is our velocity, right? So when you say average velocity, it's a slope of 55, which is that right? That shouldn't be a positive number. Am I losing my mind? Yes, I am. It should be 15 minus, shouldn't it? Wait. It should be final minus initial. Woof, we're getting there. 15 minus 15e. X, no. 15e minus, wait, what? Wait. X of 0 does not equal, wait. So does X of 0 equal 15? Yeah, that equals 1, so it should equal 1. So if we say it's at 15, here's for funsies, it seems like it says that it goes there before that. Oh, that's because I'm on the wrong thing. Oh, mega lol. Sorry. I'm a Twitch frog, yes. Why does it go there before that, though, is the question. It's probably just because it doesn't have enough accurate numbers there. That's a sig fig thing. Let's see. Let me just make sure I have the average velocity formula right. Average velocity? Yeah, delta x over delta t. So delta x, which goes from a high, which goes from 15. Wait, if it's 15e, 15e is larger. So we're going from 15, like 15e is 40. Wait. Like 15, like e to the negative 1. Negative 2, negative 3, negative 4. Yeah, that gets smaller and smaller and smaller. Think so hard about this. Why am I... It's x final minus x initial. Why is that such positive value, though? Is that not a negative value? Wait a second. Because, like, from x is 1, you're going to 15, and then x, like, yeah, x is... What if I just did... Oh, wait, let's say t equals 0. T equals 1. Okay, I can't do t equals... I lied. I can't do t equals both at the same time. T equals 0 is x equals 15. T equals 1 is 5. Why is that not a negative value? Bro. Oh, did I accidentally put in equals positive? Wait, x equals 1. Wait, no, I put in 1. E to the negative 1. It's 15 over e. Oh, I'm... Oopsies. Okay, you know, sometimes we do a little trolling. Sometimes we do a little trolling ourselves, chat. Oh my god, 15 over e. Ooh, that one hurts. Ooh, that one hurts. Oh, that one hurts. 15 over e minus 15. Oh, that one hurts. Yep, that one. 0.9, yes. Yep, 15. Oof. Woof. Okay. Yeah, that makes a lot more sense. You know, sometimes you gotta just fail again a little bit. This is 1808, so we want to, like, round it. We'll do 182 meters per second. There we go. That makes a lot more sense. That makes sense. Yeah, that makes sense. Okay. I think I probably will wrap up a little bit soon. Oh, we should do a math problem. Even though I know Storm's not here, we should still do a math problem. Should I though? Oh, it's gonna be embarrassing if I do the math problem because I know there's parts I haven't done. You know what? Fuck it. It's humbling. You guys can see that you can get better at things. That's what the stream is all about, baby, learning. Okay. What is this? What was I doing here? What was I doing over here? Oh, I started doing this too. This was just some parametric stuff. This is nothing. I don't know what that is. That was 33. Okay. We're gonna be doing problem 43. Okay. This is a problem from the parametric section of my textbook. And it is a funny little integral that we are doing. It is an arc length problem. Might be hated, but we will get there. We will get there. My computer is lagging trying to open this up. My CPU is only at 8% usage. I feel like I should really encode using my CPU, but I haven't like, I don't know if it's gonna like mess up my stream if I switch. I have like my settings up. My computer is doing better. It's like doing a lot better. I think it's because my I turned my model settings down, but it's still super snappy. Like, look at it. It's just because I don't have a lot of motion in the middle. If I had VBridger, I would change the curves and then that would be a little better, but wow, this is still loading. Kind of cringe, math textbook. Anyway, how was your guys' day? I hope it was good. What did you do? Regale me with a story. If you have one. Or not. Feels like you're waiting for like a professor to show up in class and you just don't know what to do. So you're like, where are you from? What's your major? There are a surprising amount of doors slamming. You guys can't hear them, but I can. It's fine. We could look at physics. No, that's boring. We're here for math. We're here for calculus. We're here for only calculus. Yeah, I'm like a calculus streamer. Literally haven't done calculus like forever. Oh, here we go, here we go, here we go. Oh my god, it's not even there. Bro, we're in like the middle of this book. I can't like jump to pages. Doesn't let me edit the pages. 108, that is chapter 11, okay. I'm not looking forward to doing series and sequences. Guys, let me be real. Not looking forward to that again. There's a lot of memorization. To be honest, I think I just need to like get back into math. I haven't done a lot of math in a while. Well, that's not true. I have, but it's just one of those things, you know, like you're off for like a month or two and you just kind of need to feel it out, but I don't have a lot of time to feel it out, so. Okay, was this, where's 43? That is not the one. I think it was from 10.2? Wait, maybe? We were talking about the cycloid. 43. Oh yeah, I skipped this one. Okay. Alright. It's gonna look super simple. Right? It's gonna look super simple. We're gonna do x equals t sine theta y equals t cos theta. That's yeah, t cos t, sorry. We need to find the arc length of this, okay. So, first off, you know what we're doing. We're doing that dx dt. We got that little integration by parts going, right? So, might as well do it out, right? T prime equals, or like, we can just call it like f prime. We're gonna do f prime, or we'll do this. F, G, T, 1, we got sine, and you do the minus 1 is a negative cosine. Double, we don't need to do double. That's all we need, right? So it is negative t cos t. My favorite way to do it ever since I learned it in differential equations, and I was like, bro, why did they not teach us how to do integration like parts like this? Integration by parts like this in regular math? Because I don't know why. I I honestly don't know why. This is sine t, g, that, and then this is 1. So we got, yep, t sine t. Okay, now we get to do our little thing here. So we're gonna put these together, dy dx equals, wait, no, I lied. That is not what we're doing. We're doing our arc length formula, which is slay, which is that. I like drawing integrals, they're fun. From 0 to 1. We get the square root of negative t cos t squared plus t sine t squared, which will give us, doing the right one, right? Yep. Will give us square root of t squared. Yeah, we'll just do this like this, right? T squared. If we square this, that'll be cos squared t plus sine squared t, which is going to be 1. Sorry, t. Is that right? Let's see. So this will be t squared cos squared t plus t squared sine squared t. Yeah, I don't know why this is a bad problem so far. This is going to be 1. Am I missing something? Am I missing something? I thought this problem was supposed to be hard. Let me see real quick. Let me see if I'm like doing the wrong one. Because this is not turning out to be the thing that I thought it was. I looked at this problem and I was like, that doesn't look like it's very hard. And maybe I'm right. Apparently they said that it had 1 plus, the square root of 1 plus t squared. Yeah, 43. 43, that is the problem we're doing. What? Bro, this is not, what? How do you get 1 out of this? Okay, maybe I'm like already messing up. Let me like make sure. You square the dx squared plus that. You pull out a t. You don't get a plus 1 in your square root though. You just get like this equals 1. And then it's t squared. Am I losing it? Okay, we gotta check the answer for this one, chat. If the answer for this is like basically like 1 or something close to 1, then I'm gonna call these people out on like what the hell were they doing. If it's like pi or something, or like, I don't know, secant. They said it was like square root of what? Sorry, it's gotta load again. But I mean, like, we can think about this. Let me just like check the arc length formula. Like arc length, parametrics. I spelled it wrong, but that's fine. Parametrics. Yeah. X prime t squared, y prime t squared. What? Huh? What? Unless I got my dx wrong? Let's see. Do a little graphing on Desmos to figure it out. Right, so we got t sine t. Final do x sine x. Right, x sine x, and then dx. I love ddx. I love Desmos. You can literally check anything on Desmos, is the thing. Let me just do this. What? Bro. Come on, give it to me. Okay. It's not, it doesn't wanna. Oh, does it not allow like trig functions? What do you want to take? Oh. Other way around. My bad. Okay, yeah, x on x, and then we have negative x cos x. Oh, whoopsies, whoopsies, what did I do? Is it not negative? Wait, that's not right either. What did I do here? T sine t. I just messed up my integration. I mean, it definitely messed up my integration to parts, but How? Why? Is it like 2? No. What? It's like so close. What is up? What is up with that? Wait, let me just check like integration by parts table method. Tabular method, yeah. Yeah, first integral of... I mean, sine is, like, if you do negative cosine, you get sine, right? And it's all just t, so it shouldn't be. What? Am confusion. It should be negative. What? Can I do d dt? T sine t? No, it won't let me do d dt t sine t. That's funny though. Why? Hello? Hello? Oh. Oh, I'm stupid. It's taking the derivative. Oh, bro. Oh my god, I'm out of it today. Of the integration by parts, yes, integral equals ddx. Oh, okay, you know what? We can have a good laugh over that one. POV, Damie is so ready to do the tabular integration by parts that he integrates when he's supposed to derive. Bro. Oh, okay, that's funny. Okay, yeah, sine t plus t cos d. Bro, that's so funny. Sine t plus d cos d. Oops, sine x plus x cos x. There we go. Oh my god. Why is it not working? Why is it not working? Cos t plus... No, now I see why this problem's annoying. Now I see why this is gonna get... Okay, okay. Bro, I failed the first fucking step. Oh, it's fine, it's fine. Okay. It's so funny to me. Minus. What the... What happened? Okay. Minus t sine t. Oh, okay, that was a little embarrassing. That was a little funny, a little silly. Me, why is this problem so easy? Maybe because I changed the problem. I love it when I do that, it's so funny. This is what I mean by, like, I gotta get my math brain back on. That wasn't even me being bad at math, that was me being bad at, like, reading, bro. Okay. Yeah, so... Goes t minus d sine t squared. Okay. We need like a lot of space to do this one, I think. Okay, so what do we get? We get sine squared t plus 2t cos t. No. Oh my gosh, t cos t sine t. Sine t, right? Plus t squared cos. I think it'll cancel stuff out. Cos squared t. Plus cos squared t minus 2t sine t cos t plus t squared sine t. Yeah. Yeah, we good with that? These will cancel because that's 1. I shouldn't do that, I should do like this. Wait, yeah, 1. So we get 1 plus t squared cos squared t. Oh yeah, here we go. The t squared, yeah, 1 plus t squared basically. We don't even need to like do the rest of it. Okay, now we need to remember how to do this, right? Trig substitution. Gotta look it up instantly, because I didn't actually learn this in calc. But I learned it, like, myself. Trig substitution. Paul's notes, my boy. Okay, here we go. We're gonna actually... You guys get to see this. Where's Paul? Where's Paul? Paul's notes. Oh my god, I just knocked everything over. It's fine. Alright. Wait. Okay, let's read. I'm already not reading. This one is like a lot, right? Okay, both of these use... Let's take a look at the following integral. Okay, evaluate the following integral. Wait, that's... Oops. In this case, it will not work. Yeah. It'd be nice if we could reduce the two terms in the root down to a single term somehow. The following substitution will do that for us. We use secant. Don't worry where this came from at this point. So if we say x equals 2/5 secant, and then this is saying, let's verify that this will reduce it. 25x minus 4, so we do we plug that in, minus 4. 4 times secant squared minus 1, 2, and then this is tangent squared. So then that's 2 tan theta. Okay, got it. Yes, it equals the absolute value bars. Now let's do substitution to see what we get. So we do dx equals sec theta. Oh god, I have to remember that. I hate remembering those things. I don't even know if I know that. So with this substitution, we are able to reduce it. Okay, and then you have to do that. Then you do that. Okay, got it. Oh, okay, so they're using theta, so now we need to write our answer in terms of x. We can do some right triangle trig. Bro, what? Oh, okay. Okay. This is, why is this so big brain? Oh, what? How, what? What? Why do I know what? Why are they doing this here though? Oh, what? Wait, but why are they doing that there? Equals 2 times, oh, I see, okay. That's just like this thing. Okay, that was scary. Okay, here the limits won't change, so substitution will remain the same. Limits here won't change the substitution. Yes. So how do we know if I have to do... I think I have to use secant or tangent. 9 minus x squared. How do I know it's secant? Or tangent? A squared minus... Wait, what? Bro. My brain. If... What? A squared plus... Wait, so you use sine? Oh, okay. Let us know how we use the substitutions, yes. Okay. Secant squared minus 1. Does the differential work? Had we used these trig functions, we would have picked up an extra minus sign. So while these are used generally, while these could be used, they generally aren't used to avoid. Okay, got it. Got it. So if we have, okay, I see. So in our case, we have 1 plus t squared. So this is a plus b t squared. So we want to use sine and cosine. So we're going to use sine, right? Tangent. We're going to use tangent. Wait. So if it's a squared minus... I gotta think it over in my brain. It's expanding. My brain is getting bigger and larger. Oh, sorry. Okay, so if the x is first, okay, so we want to use either secant, sine, or tangent. All right, let's just okay, you know what? Let's do this, chat. Let's look at these and see if I can guess which ones they are. Secant, sine, or tangent. Okay, this is a plus, so that's tangent. Right? I just want to look at these and see if I can hide solution. This is a minus, and the x is second, so that would be sine, I think. Right? 1 minus sine equals cosine. Yes. Yeah. And this is the x is first, so use secant, because secant plus 1. Right? Yes. Okay. This one, the x is also first. So if, oops, let me close this. So if, let me just write a little note for myself. So we have two possibilities. X first. X. Oh, we'll do a question. X position. I like doing flowcharts for this stuff. So X position. So is it first? Or is it second? If it's second, we want to use tangent, right? And theta. Right, because 1 plus tan equals secant? No? Maybe? Yes? Let's see. Yes. If x is second or first, right? But if it's first, is it plus or is it minus? Or, well, if it's plus, then, you know, it goes over here. Wait, if x is, I should say if it's, wait, oh, it's okay, we'll get there. Is it plus or is it minus? Oh, god damn it. Plus or minus? I don't want to speed through this. Let's go slow, and I'll write it down the correct way. I won't try and guess. Plus or minus? If it's plus, we always use tangent. Tan theta. 1 plus tan theta squared equals sec theta. Right? If it's minus, then we go to x position. If it's first, or if it's second. If it's second, then we use sine theta. Because 1 minus sine theta squared equals cos theta. If it's first, we use secant theta, because secant squared theta minus 1 equals tan squared theta. I think. Well, it's going to take me a bit to get used to. I've done it like a little bit, but I've never really had to do it. So, right, in this case, we would have t equals tan theta, which means we would get the square root of 1 plus tan squared theta, which is the square root of secant squared theta, which is just the integral of secant. I think. Well, it is the integral of secant. That's not the, but this is still d theta. So then we have to do some other crazy stuff. You know what? I think this is a good place to call it for tonight. I think we got a lot of good stuff done. I will probably stream tomorrow at, I don't know, maybe I'll do like what's a good time? I would like to do 12, but I think maybe I'll do closer to 2, which is 5 p.m. EST. Because I have line dance from 10 to 12, and then I have, I'm gonna go out to lunch. So yeah, probably closer to 2 or 2:30. So yeah, I hope y'all can hang out, come hang out. Or I might stream on Sunday if I realize that like it would make more sense, but I could just stream on Saturdays and Sundays. I don't know. There's no reason not to, unless I finish all my work. So yeah, I hope you guys had a good time. I had a good time, except for doing all the busy work, but you know, I like talking to you guys while I do busy work, because better than not doing anything while doing busy work and having to just turn my brain off. So thanks for hanging out with me. Love you all. I will see you probably most likely tomorrow, because I would like to get this physics done. But you know, if not, then we'll do Sunday. Or maybe we'll do both. I don't know. I didn't tweet about this, I just realized, but you know what? It's not a big stream, so I don't particularly need to tweet about it. But alright. Love y'all. I'll see y'all later. Have a good day. Hope you have a good time with math problems and life and all things of that nature. I will see you next time. Bye!